Alright, hi everyone, welcome to my YouTube channel, City of Electrons, and in this video we'll be talking about this past question. Not just this one, this and the next, because looking at this past question that talks about modular design technique is believed to be the best in the research and development circle, R&D circle, okay? As part of your lecture to a group of young engineers, discuss the various design techniques, stating, that should be stating, okay, I have one T here, we have another T here, yes, stating their advantages and disadvantages, okay? Now, guys, we have made a video like that before, yeah, we have made a video like this before, so this YouTube channel, City of Electrons, and you see EEE 555 number 1, design definition and approaches. So in this video we talked about the modular design, modular circuits, things like that. Okay, so although this video is not exactly directed to this question, but you can see modular design there and other design techniques, so no need to remake the whole thing again. So we'll just leave this question here and go to the next question. All right, so in the next question we are asked to design a power system, okay, power supply unit. So a laboratory workbench needs to, let's expand this. So first of all, let's understand the question, okay? Let's understand the question. Now, a laboratory workbench needs to be fitted with a multiple power supply unit. You are required, that's all of us now, okay? We are required to design a PSU, power supply unit, that provides the following: positive and negative 5 volts, positive and negative 9 volts, positive and negative 12 volts, positive and negative what? 15 volts. So we have to give a detailed design description specifying the components needed. Okay, we can also make use of block diagram, of course. Block diagram will just make this easier. Now understand this. I want to talk about 0 volts. This is ground. Okay, above 0 volt is what? 5 volts, positive 5 volts, positive 5 volts, positive 9 volts, and so on. Below 0 volt is what? Negative 5 volts, negative 9 volts, and so on. Okay, now this 0 volt, which is the reference voltage, positive voltage can have it like this, negative voltage down. Okay, now this having negative and positive voltages is important when we get to deal with amplifiers, because when we have input signal, if we want to give output signal, and let's say we have only ground and positive volts, the output signal will only contain signals in the positive side. We only have half of the signal. But if we are having positive and negative voltage, we'll have both the positive side of the signal, and the negative side of the signal. Okay, so how do we create negative voltage? Now that is part of our design. So this is the question. Okay, the idea is that inside lab, let's say you have a bench. We have in the lab, you have something like a bench. Okay, something like a bench in the lab. Okay, and on the funny table, and on the workbench, you have a socket, different sockets, and each of these sockets you can connect things to. These are power outputs, and each of the power outlets, you have different voltages coming out of them. Okay, so 5, 9, 12, 15, positive and negative, just like that. Okay, so how do we design this power supply units? How do we design that? Okay, now first of all, the PSU, which is power supply unit, converts what? AC main voltage into DC regulated voltages for us to use in the lab. Okay, DC regulated voltages into regulated DC voltages required by what? Electronic circuits. This design provides what? dual polarity. Polarity. This is one polarity. This is another polarity. So dual, that's two polarities. Okay. So dual polarities or dual polarity output. Yes. So yeah, 5, 9, 12, 15. But the 5 you have positive 5, negative 5. The 9 you have positive 9 and negative 9. Are we following? And so on. So these outputs are suitable for analog and digital laboratory what application. Let's look at the block diagram of our design. So AC supply will come in. That's one. Yes, we agree. When that AC supply come in, we are going to pass it through a centered taped transformer. When we say centered tape, now, guys, bear in mind that this AC supply that comes in, you have now the AC supply that comes in, it is not positive or negative. It is not positive or negative. AC is alternating. So at some time, this side will act as the current electrons will flow like this, and they will flow back. They will flow like this and flow back. So the current is alternating. Flow, flow. Okay. The current is alternating. So you can't really say, oh, this side is positive, this side is negative. No, 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 no. At some point, this guy acts as positive, this one acts as negative. At other time, this one will not act as negative, this one will not act as positive. But they switch very, 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 very fast. They switch very fast. Okay? So the speed at which they alternate, in 1 second, that gives us the frequency, that tells us the frequency. So if they say this AC supply is at 50 hertz, what it means is that it is alternating sides, it's changing side 50 times in 1 second. Okay, 60 hertz means 60 times in 1 second. That's how fast it is. Okay, so yeah, that's for that. So that's what we get in. But remember, what we need as our output is what? We should have one side that is positive, we should have one side that is negative. Then 5, 9, 12, and 15. Are we following? So what this our AC supply now is coming as AC, not our DC, because this is DC now. This is DC. You have positive and negative. It's DC. So AC comes in, and this AC is also high. It's not to a certain whether 5, 9 or certain voltage. So it has to come into a centered tape transformer first. So what a centered tape transformer does is this. Transformers has primary winding and secondary winding. Okay, so for a step down transformer, this secondary winding serves as the output, and of course the voltage that comes out of this is less than the voltage in the primary winding. That's a step down transformer. Okay, step down transformer. So this our step down transformer is not a normal step down transformer, it's a centered taped transformer. What does it mean? It means that in the secondary winding, serving as the output, which is giving us lower voltage than the inputs, okay, lower power than the input. So this our secondary winding is divided into two. This our secondary winding is split into what? Split into two. Oh, excuse me. It's split into two, like this. One part, at one end we have what? Let's say 1 voltage. At the other end we have another voltage. At the center we have what is 0 volts. So in our design here, this side is 18 volts, this side is also what? 18 volts. So it has been stepped down from what comes into what? 18 volts, 18 volts, and the center is what? Ground. So we are having what? 3 outputs. 1, 2, 3. 18 volts, 0 volts, and what? 18 volts. Are we following? So with this now, it is still what? It is still alternating current. It is still alternating. So this side is sometimes positive, this side will not be negative. It will switch again. This side will be negative, this side will be positive. Very fast. But of course, we have this one as ground. Now, since we have achieved one thing, meaning we have stepped down the voltage first of all, we now have 1, 2, 3 output. What's going to happen now is that, of course, 0 volt goes as our ground wire. These two guys, Okay, we are going to pass them through a bridge rectifier. What the bridge rectifier does is to convert this AC to what? DC. Are we following? So one side will now become what? From the bridge rectifier, one of the sides will now be what? Positive. Let me write that positive where? Better, positive. And the other side will be, let me use a different color for that. This will be positive. And the other side will be what? Negative. Oh shit. The other side will be what? Negative. Now we have positive 18 volts and negative 18 volts from our bridge rectifier, and we also have 0 volts. So now, as you can see, we now have DC positive and DC negative. All has been stepped down to 18 volts. Positive 18 volts, negative 18 volts, and 0 volts. Now, but what do we need? We need what? 5, 9, 12, and 15. So before we get to where we now regulate them, regulate the positive and negative voltage, we have what? Filter capacitor. You know, this thing came from we came from AC supply to center tape transformer to bridge rectifier to stabilize this voltage, okay, or to filter, like, you know, these sudden spikes in voltage and things like that, not the voltage not being smooth, all those spikes and things like that. That is where we have filter capacitor, okay, to filter out noise, to give us a bit of balance. Let me use the word balance, okay, but kind of to filter out noise. Now, also filter the received voltage. Now, that's what this guy does, filter capacitor. After that, the positive and negative voltage is this and this, okay, this and this. So the positive and negative voltage is what? Regulated. So they are regulated using voltage regulators. So we'll now use a voltage regulator to give us one voltage regulator will give us positive 5 volts. Another voltage regulator will give us negative 5 volts. Voltage regulator, okay. Oh. I made a video on a voltage regulator, but that one I used for just positive 5 volts. And I think I should show you that video now. You can watch that video here. Yeah, I'll show you that video. Okay, so this is a video where I talked about how to connect a voltage regulator and see it work. So the voltage regulator is right here. Okay, so just watch this video and you see what I'm talking about. So that means for each of them, for positive 5 volts, negative 5 volts, positive 9 volts, each of them we have voltage regulator for each one. The voltage regulator will do what? It will take in, listen, the voltage regulator will do what? It will take in positive 18 volts and give out positive 5 volts. That is for a 5 volt voltage regulator. Then it will take in positive 18 and give out positive 9, positive 18, positive 12, positive 18, positive 15. Exactly. Then it is now taking negative 18, give you negative 5, negative 18, give you negative 9, and so on. So different voltage regulator will be used for it. So with that being said, how many voltage regulator do you think we need? Come on, guys. 1, 2, 3, 4, 5, 6, 7, 8 voltage regulator. Okay. And after that, we'll now have our output as what? This. We'll finally have our output voltages. Okay. Design description. I need to read this. I have explained everything. I've explained everything, guys. So yeah, the design description. First thing is the transformer stage, which is what I explained. Look at the 18 volt, 0 volt, and 18 volt I talked about. Okay. And in the rectifier stage, okay, like what I talked about, the pulsating DC. A bridge rectifier converts the AC voltage into pulsating DC voltage. So the components, 4 power diodes. Okay. Filter stage, large capacitor electrolyte. So a large electrolyte capacitor are used to smooth the rectified voltage and reduce what? Ripples. Okay. Now for the voltage regulation stage, yeah, now this is it. I said this is for the positive voltage regulators to give you positive output. The name of the voltage regulator tells you what they are doing. If you see 7-8, know it's a positive voltage regulator. Are you seeing the 8? Positive 8. Sorry, 7-8. 8 after the 7 means positive. 8 positive, 8 positive, 8 positive. When you see 9, it tells you it's a negative voltage regulator. 9 you see negative, 9 you see negative, 9 you see negative. Okay, then if you see this last two digits, tells you the output of the voltage regulator. 05 is what? Output of 5 volts. So 805 positive 5 volts. 809 positive 9 volts. 812 positive 12 volts. 815 positive 15 volts. Are we seeing it? Then for negative voltage regulator, the name and 9 tells you negative, and then what do you have there? 05 905 negative 5 volts, 909 negative 9 volts, 9012 negative 12 volts, 9015 negative 15 volts, plus blah blah blah. Okay, now of course heat sinks are attached to the regulators to prevent what? Overheating. For our protection components, we add fuse to prevent overcurrent. Okay, for overcurrent what? Protection. We're also going to add power switches to, so that we have the option to turn on and turn off the power output power. Of course, add LEDs to serve as indicators. Then add bypass capacitors for noise filtering. We already talked about capacitors in the filter stage. Okay, and then yeah, so that's basically it. So the circuit operation, for circuit operation, the transformer reduces this kind of just like conclusion stuff. It's kind of the same thing again. The transformer reduces the AC main voltage and produces dual AC outputs. The bridge rectifier converts the AC into DC, while the filter capacitor smooths the voltage. The regulator's ICs then provide stable positive and negative voltages output required for the laboratory works experiments. So these are the components used: center tapes, transformer, bridge rectifiers, which is diodes, electrolyte capacitors, and all these voltage regulators. These are the positive ones. These are the negative ones. Then of course heatsink, fuse, switch, and LEDs. And then for conclusion, the designed power supply unit provides regulated dual polarities outputs. This, and this, suitable for powering analog and digital electronic circuits in the laboratory work environment. Okay, so that's it, so guys. That's it. So comment, like, share, subscribe, and I'll see you in the next one. Thanks for watching, and bye for now.